The oceans that give Earth its famous blue marble look are a huge part of what makes our planet a decent place to live. But even though it's the only planet we know of that has oceans on its surface today, a new model released by the NASA Goddard Space Flight Center last week predicts that ocean worlds are far from rare. And that's a big step toward figuring out how habitable other planets in our galaxy might be. Now, we're not just talking about planets with oceans on their surface, like Earth, because even in our own solar system, we've seen that some bodies have oceans below the surface, like Jupiter's moon Europa and Saturn's moon Enceladus. And oceans like theirs could potentially support life too. So the authors of the study wanted to get an idea of how common any oceans are in the rest of the galaxy. But we don't actually know that much about most exoplanets. If we're lucky, we know their mass, radius, and distance from their stars. Fortunately, that's actually still enough to draw some conclusions. Like, for a planet to have any kind of ocean, it needs to be solid. So the researchers started out with a sample of 53 exoplanets no more than twice the radius of Earth or 8 times its mass. That should rule out the gas giants. From there, they used what little data they had on those planets to guide their model. For one, since the authors knew the mass and radius of each planet, they could calculate the average density. Water is less dense than rock, so too high an average density would rule out an underground ocean. Then, to gauge the possibility of an above-ground ocean, the authors calculated what's called the effective temperature. That's just the surface temperature assuming there's no atmosphere. They could do that by using the brightness of the host star and the planet's distance from it. Too high an effective temperature and any surface water would just boil off. Too low and the surface water would be totally frozen. But in those cases, the planet could still have an ice shell and an underground ocean. They also factored in a number of other details, like estimates of how much internal heat the planet was producing based on its size, age, and what we know about internal heating in bodies in our own solar system. So in the end, putting all those calculations and assumptions together, the researchers' model showed that about a quarter of the planets could be icy bodies with oceans, mostly underground ones. Of course, actually finding those oceans and probing them for life is a whole other story, but now that astronomers know that these oceans are probably pretty common, they can start to look for them. One way they might do that is by looking for water spewing into space. This is how scientists discovered water on Enceladus. And that's one thing the James Webb Space Telescope can help with when it launches in 2021. At the same time, this telescope will also give us a completely new look at exoplanets and their atmospheres, so we can get a better idea of their composition and how habitable they may be. But even with all these new potential ocean worlds to study, scientists are of course still interested in the ones in our own solar system. For instance, in 2015, the New Horizons mission found evidence that Pluto, that oddball that we all assumed was just a frozen rock, has an underground ocean. And just this past Monday, scientists published a study in the journal Nature with evidence that Pluto may have had a much more exciting history than anyone expected, and that it may have had an ocean since right after its birth. See, scientists generally assumed that Pluto formed out of cold matter and has always been cold. But how a frigid planet could form an underground ocean was not an easy question to answer. And in the latest study, scientists explored the possibility that Pluto didn't begin as a frozen rock. To start off, the authors built a model that predicted what types of surface structures we should see if Pluto got a cold start. Their model showed that its rocks would have gotten compressed and the surface would be dominated by big ripples of folded rocks. On the other hand, the model showed that if Pluto had gotten a hot start, its rocks would have gotten stretched apart, and that would produce features like ridges and groups of faults where the land is either pushed up or down. And images from New Horizons show that those features are actually much more common, implying that Pluto started off hot before freezing over. This could have happened if Pluto grew super fast, with lots of impacts in quick succession, which would have built up enough heat to make a liquid ocean possible. And while that heat dissipated, other factors could allow the ocean to persist, like heat released from the radioactive decay deep inside the planet. If that's true for Pluto, it suggests that it could have happened to other objects in the Kuiper Belt as well, and that means that ocean worlds in our solar system could be much more common than we thought. So by exploring bodies like these both inside our solar system and throughout the galaxy, we'll start to get a better idea of how many worlds out there could be home to life. Thanks for watching this episode of SciShow Space News, and if you want to learn more about the oceans on other worlds, you can check out our episode about the massive ocean on Enceladus right after this.